The goal of Lab 5 is to determine the formula of a hydrate. So hydrates are a special kind of compound. The formulas for them are written like this. And basically what we have are water molecules that are trapped inside the structure of this copper sulfate. So hydrates are in fact solids. So even though we see this H2O, we don't actually have a liquid. So we have solid copper sulfate. We're going to refer to that as the pure salt. And actually what we have are water molecules trapped inside the structure of this salt. And what we're looking for in this lab is to figure out the formula for the hydrate. So we already know it's copper sulfate. We know waters are trapped. We're really trying to figure out how many, and then we'll repeat that procedure with another hydrate. Magnesium chloride is the pure salt in this one. So let me give you an example of one with its formula. So this is sodium carbonate, and we call this decahydrate. So inside this structure of this salt, there are 10 water molecules trapped for every one of these. So when we heat the compound, which is what you're going to do in the virtual lab, when we heat it, we're left with sodium carbonate, the pure salt, as a solid, and the water molecules are going to heat up, start to wiggle faster, and then leave as water vapor. So the water will leave in the gas phase. So what we're going to look for is enough data we can collect to figure out this mole ratio. So we know coefficients in a balanced equation are a mole ratio. If we can figure out this mole ratio, that will tell us how many waters were there to begin with, and then we'll be able to determine the formulas for our hydrates. So the type of data that you're going to collect, it's going to be done in a little porcelain cup called a crucible. So of course we need to know the mass of the crucible without anything in it. And then we're going to add the hydrate. So that'll of course be the mass of the crucible with the original compound called the hydrate. So water is present at this point. And then we're going to heat it. And it'll take a couple minutes. During the time that you're heating it, that's when the water is going to leave. And then you're going to measure the mass again. So this last mass will be the mass of the crucible and what your lab refers to as the pure salt. So what I'm going to do is just work you through the calculations for, let's say, copper sulfate, the copper sulfate hydrate. So with these three masses, we actually have enough information to figure out the formula. So of course when we measure something in a device like a crucible, we have to subtract out the mass, of course, if we want to know what's inside. But if you notice here, the mass with the hydrate and the mass after the heating, the difference in these two should tell you how much water left. And that would give you the grams of water that were originally in your hydrate. And then if you focus on this compound, this data here, the mass of the crucible and the pure salt is just the copper sulfate. And if you take this data and subtract out the mass of the crucible, that will tell you just how much pure salt you have. And that will be asked in question 2C. The mass of the water is asked in 2A. So if we understand what we're measuring in each of these three masses, we should be able to figure out how much water left and how much copper sulfate remains. That's all the information that we need to complete the calculations. So you will know from 2A how much water left, and we can easily convert those grams of water to moles of water using the molar mass of H2O, which is 18. So when we do this division, we're finding moles of water present in our hydrate. Now, this is going to be a small number because we're only working with a small amount of hydrate, and I would encourage you at this point not to round your answers. So question 2b is how many moles of water are in your compound, and then likewise you're going to take the mass of your pure salt, which you'll know from 2b, and you're going to convert it to moles as well. So the only thing we need here is the molar mass of copper sulfate. So I'll let you figure that out. It'll be 63.5 plus 32 plus 64, so whatever that is. And that'll tell us moles of copper sulfate. So that's the question in 2D. From there, we're just looking at this ratio. And so you're asked to find the ratio of water to salt, and it tells you in the lab exactly how to do that in part 2E. It tells you to divide your moles of salt into moles of water, and let's just say, just for example, that you get a ratio of 3 to 1. So what does that tell you? It tells you that there are 3 moles of water for every 1 mole of salt. So if this were in fact what you would get, then you can write from that the formula for your hydrate. So if this were your data, then you would be able to determine the formula for your hydrate is CuSO4.3H2O. So follow this example exactly for the other hydrate, magnesium chloride, and you should be able to determine its formula as well.